Assalamualaikum. My name is Nursha binti Rahimi. I have two other friends with me, which is Muhammad Nasri and Ahmad Irfan. We are from Group 11, which is we do IoT-based automated aquarium. So let's see what we have done for this project.
IoT-based automated aquarium specific goldfish. In product background, IoT-based aquarium is helped to monitor the fish, which is goldfish, and their needs such as water level, the aquatic temperature, turbidity level, sufficient food level, and pH level by using application in smartphone. In objective is to deliver user-friendly web and display to an application to monitor the monitoring system. Next, to deliver monitoring system to monitor water quality such as pH, water turbidity, water temperature, and water level. And the last one for objective is to deliver an automation system to maintain the food and filtration.
Thank you, Nasri. Now, we'll proceed to the benefit and potential market. For your information, our project is user-friendly, which means it's easy and simple to use. Besides, the project also is an eco-friendly aquarium. It also able to reduce time from doing manually maintenance such as cleaning and feeding. Then we will go to the methodology and material of this aquarium project. As you can see, there are two types of microcontroller that we use, which is the Not MCU ESP8266 and the Raspberry Pi Model 3B+. There are also four types of sensor that we use to read, which is the pH sensor, ultrasonic sensor, turbidity sensor, and temperature sensor. The Not MCU ESP8266 will collect the data from the sensor and send it into the Blink application. We can install the Blink application to display or see the value of sensor. Besides, the Not MCU ESP8266 also will send the data through Raspberry Pi, which is the Raspberry Pi has been set as the broker, and it will go into the Node-RED web server. Not MCU send the data in MQTT, which is the MQ telemetry transportation. The Raspberry Pi will trigger the output that we use, which is the pump motor, feeder, and lamp, based on the specific requirement. As you can see, at the right side of the slide, you can see the smartphone apps of Blink, and the bottom is the dashboard for the Node-RED. At the bottom, you can see the overall circuit of the project. Fabrication and procedure. This is the flow chart of our monitoring and automation system. First, the sensor will read and the value will be displayed into the Blink app and Node-RED web server. If the requirement below, as you can see below, is not achieved, and then the Raspberry Pi will trigger the output, which is the motor pump, lamp, and the motor pump with filter to make sure the specific requirement has been achieved.
Next, I'll show you the result that we got in 6 days. For day 1, we took the test in the morning and we got 8% of the BTP. It happened because of fish waste itself that accumulated in the aquarium. This also will affect the water pH level. At the same time, during the test, feeder just released the food. TB and pH result will affected also. However, motor filter will keep running to reduce the percentage of TB. Next, as you can see here, the value of temperature has shown different in the morning compared to the evening. By the articles, the suitable temperature for both fish is 21 Celsius until 25 Celsius. when the water gets too warm or too cold, it will affect their growth or productivity. By the result of temperature, we do some observation on function of lamp. The lamp will turning on when the temperature below than 21 and off when the temperature reach 24 Celsius and above. We also monitor our automatic feeder to observe the function and their action in 6 days. At the same time, water level also increased, which has slightly lost the level of water inside the tank. In this project, we use several types of sensors such as turbidity sensor, pH sensor, ultrasonic sensor, and temperature sensor. The motor pump filter controlled by turbidity based on our calculation that we use voltage output from the sensor. Next, the other motor pump will control by the value of water level. We use 2 ultrasonic sensors to sense the distance of water level and the level of food in the fish feeder. We also attach the pH sensor to monitor water quality. It will display on the Blink and Node-RED website. Next, we use temperature sensor to control on or off LED. It depends on the temperature. Actually, the purpose of LED is to release the heat into the water and stabilize the temperature for fish growth.
Okay, let me show you the result. This is for water level. When the distance of water level with the ultrasonic is more than 8 cm, and then the water pump will on to supply the water. For a few minutes, the water will increase. Okay, so this is for percentage of turbidity. Here is 7% of turbid for this water. And as you can see here, the motor will keep run to filter the water to reduce the percentage of turbid. So let me show the difference when I submerge the probe into a clear water. So I take the probe and submerge into a clear water, and let me show you the result. For now, it's 5% of turbidity. So for in few minutes, the percentage of turbid will decrease until 0%, and the motor will stop running. This is because I submerged the probe inside the clear water to show you the difference when the motor runs, when the motor stops. So this is for temperature. As you can see here, for current temperature is 25 Celsius. So the LED is still off. Let me show you if we submerge the probe into the cool water, which is when the temperature decreases. It will turn on the LED to release the heat. And this is auto feeder using real-time clock, which is when the system start and run, the real-time clock will start counting, and this auto feeder will release the food at 10 AM and 10 PM, twice a day.
For Raspberry Pi, we use as a control the relay or trigger the relay, and then we use 2 microcontroller. The light blue means transfer data to Raspberry Pi to turn on all the sensor, and then we use 4 baud relay, which is 2 relay control motor pump, and then the other one relay is control LED. For servo motor, we used to control the food to get a fish twice a day. And then for LED, we use source as battery 5 volt, and LED is 12 volt. We use step up to avoid LED spoil. We step up.
Next, let us continue with the node lab. As you can see, in our left side is the palette. We call this section as the palette section. We can use any palette to trigger the input or the output that we want to use. We can customize the palette by sorting at the dashboard to create the requirement that we want. For an example, this is the system that we have used to display the sensor value and to trigger the motor for our project. You can see in our left side is the turbidity input, the pH input, temperature input, the water level input, and the food feeder input. This input is the signal that had been sent from the node MCU, and then it will go to the gauge. We can see the value in the user interface section. For the motor pump, if the requirement say that the value need to trigger the motor, the input will go to the delay, so that the motor will run, but before there will be a delay for 1 second. This concept is also same with the other pin. Okay, next we go to the user interface. This is the user interface. We can create the type of the pattern, the design of the user interface that we want. As you can see, this is our pH, turbidity, temperature, food feeder, and water level. We can also make a graph of the sensor at the bottom. You may customize based on the design that you want.
At the end of this project, we can conclude that we achieved the objective to the development of monitoring system for the water quality of the goldfish aquarium using IoT. This system can be used to monitor the temperature, pH level, and percentage of turbidity. Last but not least, we managed to face the problems during this progress. That's all from us. Thank you.